Hello students, in this video we're going to learn about normal distribution and please I hope you have the worksheet along with you because we're going to solve all the problems in the worksheet on normal distribution. Now before we start solving the problems, let us see some basics of normal distribution. If we take, this is the y-axis and this is the x-axis, so y and x. Okay, now this will be 0. Now we know that z, that we have a bell-shaped curve like this here. Yeah, this is the curve of z, where which has mu, the mean 0 and standard deviation 1. Now we know that this area, this area is 0.5 and this area is also 0.5, isn't it? This area is 0.5. So we know that this curve is actually symmetric about the y-axis, right? So if I say p of z more than 0, so basically the probability will be given by the area under the curve. So the area under probability of z more than 0 is 0.5 and probability of z less than 0 is also 0.5. Yeah, this is one thing. Now if I take this is 0, if I say p of z more than 1, which is nothing but, so 1 is here, so p of z more than 1 is nothing but this area. Yeah, and since the curve is symmetrical about the y-axis, if I take -1 and if I find this area, that means z then -1, both are same. So p of z more than 1 and p of z less than -1 will actually be same. Yeah, similar. Of course in the diagram doesn't look like it, but they are actually same. So same way, p of z more than 2 will be equal to p of z less than -2, or p of z more than 0.5 will be same as p of z less than -0.5. Yeah, very, very simple. Now how do you find these probabilities using a calculator? Let's say suppose I want to find p of z more than 1. Okay, now if I try to draw this, so this is y-axis, x-axis, so this is the curve, bell-shaped curve. So 1 is this, so I want p of z more than 1 means I want this area, right? I want this area. So what you need to do is take a calculator, the Casio FX9860G2 calculator, go to statistics, go to distribution, enter distribution which is above F5, and then enter normal, okay, which is above F1. Then you'll see three options: NPD, NCD and inverse normal, INVN. You need to enter NCD. Okay, now you'll have the first one is data. You'll have data, which is nothing but variable, not the list, variable. And the second one is you'll have lower and upper. Okay, now I want this area, isn't it, student? That means the lower limit is 1 and the upper limit is, now in future we'll always, you always use 10,000. So upper limit is 10,000. Okay, now next is sigma. Now sigma is this is a standard normal curve, right? This is 0, standard normal curve. So sigma is 1 and mu, the mean, is 0. Yeah, and after that when you enter execute, you'll get the answer as 0.1586 or 0.159. so this area is nothing but 0.159. so very, very simple. This is how you find it. Let us see another problem. Suppose I need to find p of z less than 1.3, for example. Then what will I do? I'll draw y-axis and x-axis. I'll draw this 0. So 1.3 will be in the right hand side of O. So here it is 1.3. I'll draw a line here. Now I require p of z less than 1.3. That means I require this area. So don't you think this answer will be more than 0.5, isn't it? Yeah, definitely it will be more than 0.5. So let me find out. So how do you find it using the calculator. Go to distribution, normal, go to NCD. Now this is the upper limit, right? So the lower limit will be minus 10,000. Always put minus 10,000. Now the upper limit is actually 1.13, and sigma is 1, same, mu is 0. So you'll get 0.903. You get 0.903 as the answer. Okay, so let me find P of, let's say, Z more than minus 0.6. So how do you find it? You draw the y-axis and the x-axis and the standard normal curve, and minus 0.6 will be in the left hand side. So let us say this is here, minus 0.6, and draw a line. So I require this area, isn't it, students? And as you can see, definitely this answer will be more than 0.5. So how do you find it? Take a calculator, go to distribution normal, go to NCD, which is above F2, and then now this is the lower limit and upper limit is 10,000. So lower limit is minus 0.6, upper limit is 10,000. Sigma is 1, and standard deviation is, that is, sigma is the standard deviation is 1, and the mean is 0. So you'll get 0.7257, so 0.7257, so 0.726. In the examination, please don't overwrite it, students. You can cancel it and write 0.726. Yeah. Let us see one more. Example. P of Z less than minus, let's say, minus 2. So if I draw, then it will look like this. So minus 2 is here. Draw. I want this area. So definitely you can see the area will be less than 0.5. So how do you do it? Students, go to calculator, go to distribution normal, go to NCD. Now I want this area, right? So definitely the lower limit is minus 10,000 and upper limit is minus 2. So you get 0.0227. So 0.023 is the answer. Yeah, very simple. Okay. Now let us consider this probability, students. P of Z more than A is 0.61. Yeah. So I have the probability. That means I have the area under the curve, but I don't know the value of A. Now how do I find it? How do we find it? So I have to draw the y-axis and the x-axis and draw the bell curve. This is 0. I'm sorry, it doesn't look very neat, but fine, I think it should do. Okay, now tell me, students, whether A will be on the left hand side of O or on the right hand side of O. Isn't it? I think the students always get confused to identify where A will lie. Just in case, let's say for example, you don't know. Let's say suppose A lies on the right hand side of O. That means A is a positive number. I'll draw a line. Now when I say Z more than A, it means this area. This area. Now can this area be 0.61, students? Is it possible? It's not, isn't it? Because this whole area, as I mentioned earlier, is 0.5. So how come this small area be 0.61? So definitely this diagram is incorrect. So what I need to do is I need to draw it correctly. So definitely A will not be in the left hand side of O. So A will be here. So when you draw the line, Z more than A means this area. So yeah, definitely it is possible. This is the correct one. So A will be this area. That means this area is 0.5 and this area is 0.11. Okay, 0.11 and 0.5. So totally 0.61. Now how do I find the value of A using calculator? Very simple again. Go to distribution, go to normal, Now go to inverse normal, that which is above F3. Now you will see data, which is variable, tail. Now it will ask for tail. Now you can see this is the tail for me. Okay, this is the tail for me. So the tail is right. So tail is right. So enter right. And then area. Next it will ask you for the area. You enter 0.61. And then it will ask for sigma, which is 1. It will ask for mu, which is 0. So enter those values. So when you press execute, you will get A as minus 0.2793. So minus 0.279. So this value is minus 0.279. Okay. So this is how you find the value of A. Let us look at another problem. Let's say P of Z more than A is 0.256. Just one example, 0.256. Now you draw the y-axis, you draw the x-axis, then you draw the bell curve. Okay. Now again you are not sure whether A will be in the left hand side of O or on the right hand side of O. Okay. Let us say I don't know, but I'll just draw here. Let's say A is here. Then I'll draw a line. Now tell me, students, which area is more than A? Is it the red part or is it the green part? Tell me please, which area is P of Z more than A? So more than A means right hand side. So we are talking about this area. Now according to the problem, this area is 0.256. Now tell me, students, is this possible? Can this area be 0.256? Definitely not, isn't it? Because we know this area is 0.5. So definitely the whole area will be more than 0.5. So this diagram is incorrect. So what is the correct diagram then? Correct diagram is when you draw A to the right hand side of O. This is A. I'll draw a line, and so more than A means right hand side, so this area, right? So this is the tail for me. So go to inverse normal, go to distribution normal, go to inverse normal, and tail again is right, isn't it? Tail is right. Area is 0.256 and sigma is so 1 and mu 0. So you get A as 0.6557. So 0.656. Right? So that is the answer. P of, so A is 0.656, which means P of Z more than 0.656 is actually 0.256. Now let us consider this. P of Z less than A is 0.81. Let me again draw a diagram. Y-axis, x-axis, this is 0. I'll draw the bell curve here. Okay, now I'm not clear where A will lie. Will it lie on the left hand side of O or the right hand side of O? Suppose if you mark A here, then draw a line. Now tell me which one is the correct area. Is it the red one or is it the blue one? Tell me, students. Please look here. It is given P of Z less than A. Less than A means left hand side of A. So which means we are talking about this area. So according to the problem, this area is 0.81. It is not possible, isn't it? Because this area is, this whole area is 0.5. This whole area is 0.5. So how can this area be 0.81? So definitely the placement of A is incorrect. You placed it incorrectly in the wrong position. So the correct diagram is like, it looks like this. So here I'll draw 0. A is here. I'll draw left hand, less than A means left hand side. So this area less than A. Yeah. Now definitely this area can be 0.81. So now for me the tail is left. The tail is left. So go to distribution, go to normal, go to inverse normal. Now the tail is left. The area is 0.81, sigma is 1 and mu is 0. So when you enter, you get A as 0.8778. So 0.8, I'm sorry, 8778. So A 0.878. So the value of A is 0.878. Okay, one more probability. Let me draw the diagram. Let me try to represent it. Okay, this is 0. Now P of Z less than A. That means left hand side of A. The area is 0.16. Let us say I'm still not clear where I need to place A. So let us say I try to place A here. Then I'll draw a line. Less than A means this area, isn't it? The left hand side, this area. Now tell me, students, is this possible that this area is 0.6? Not possible, isn't it? This area will definitely more than 0.5. So this diagram is incorrect. So what is the correct diagram then? A will not be on the right hand side of O. It will be in the left hand side of O. So A will be here. So this area. Yeah, so this area is actually 0.16. So where is the tail? Tail is left. Okay, so go to normal, go to distribution, go to normal, go to inverse normal. The tail is left. The area is 0.16. Sigma is 1, mu is 0. So you'll get A as minus 0.994. Minus 0.994 is the answer. Yeah, that's very simple. Now you may ask me, sir, when we go to inverse normal, there are three. When you go to tail, there is one left, there is one right, and there is also one center. So when do we use center? Now this is when. Let me give an example. Let's say P of Z more than minus A and less than A is 0.34. Then find the value of A. In this case, this is how the diagram look like, the curve. So 0. So right hand there's this A, and this minus A will be equidistant from 0, right? So draw this, and this is the area between minus A and plus A. So now in this case, to find the A, you need to enter the tail as center, CNTR, and the area is 0.34 and sigma is 1 mu 0. So you get this A as 0.4399. So 0.440. So this is 0.440. This is minus 0.440. So this is when you use center as the tail. Yeah. So I hope it's sort of clear to you, students. Let us start doing the problems. Now let us see one more example, students. Now how do you find let's say P of Z more than minus 1 and less than 2? How do you find it? So go to distribution, normal, go to NCD. Now the data is variable. The lower limit is, this is the lower limit, right? This is the lower limit, and this 2 is the upper limit. So enter minus 1 for lower limit, and upper limit is 2. Sigma is 1, mu is 0. So you get 0.8185, so 0.819 is the answer. So if I have to, I'm sorry, represent it in the standard normal curve. So this is how it looked like. This is the curve. Then you have 2 here, you have minus 1 here. So this area. So this area is 0.819. Yeah. Now the first problem in the worksheet is a random variable x is distributed normally with the mean of 20. That means mu is 20 and variance is 9. That means sigma square is 9. So this can also be written as x with this n of 20 comma 9. So now if the sigma square is 9, then it is quite obvious that sigma is 3. The first question is find P of x less than or equal to 24.5. Now how do you find it? go to distribution, go to normal, go to NCD. Data is variable. Lower limit. Now I want less than 24.5, right? That means 24.5 and below. So the lower limit is minus 10,000. Upper limit is 24.5. Sigma is 3, not 1, because it is not z, it is x, and mu is 20. Then enter. The answer is 0.933. Yeah, very simple. Now the second part is p of x less than or equal to k is 0.85. Now you need to represent this diagram. They have given a diagram like this. This is the x-axis. This is the y-axis. I'm sorry. This is not the y-axis. This is 20. So this is x equal to 20. So y-axis should be somewhere here. Okay. Now the graph of x will be symmetrical about the mean. So 20 is the mean. So the like this, like this. So x less than or equal to k is 0.85. Now less than or equal to k means left hand side of k. So definitely k cannot be on the left hand side of 20, isn't it? Because k has to be on the right hand side. Then only this area can be 0.85. So this is how. So this is 0.85. So this is this is represented in this diagram like this. Represent this information in the diagram. Next question is find the value of k. Now how do you find it? This is the tail for me. So the tail is in the left hand side. So go to distribution, go to normal. Now they have given you the area, isn't it? So you need to use inverse normal. So inverse normal, tail is left. The area is 0.85. Sigma is 3, mu is 20. The answer is k equals 23.109. So 23.1. A very simple problem. Okay, this is the second problem, students. Let the random variable x, that's a random variable x, be normally distributed with mean 25 as shown in the following diagram. So mu is 25, the mean is 25. Now the shaded region between 25 and 27 represents 30% of the distribution. That means they are saying this area is 30%, that means 0.3. The first question is find p of x more than 27. That means I need to find this area. Now as you may recall, this area that is above 25, the area is 0.5 and this area is 0.5, isn't it? So obviously it is quite easy to note that the answer is, that means the shaded area, the green part, is nothing but 0.5 minus 0.3, which is 0.2. So p of x more than 27 is 0.2. Now the second part is find the standard deviation. Now how do we find the standard deviation? Yeah. Now to find the standard deviation, you need to follow these steps, students. So now let us take, let's say A is more than B. Then if C is a positive or negative quantity, whatever it is, then A minus C will definitely be greater than B minus C, isn't it? Yeah. Suppose I divide both sides by a positive quantity D, then A minus C by D will definitely be bigger than B minus C by D. This is actually a true statement. Okay, all these are. So the first step implies the second step, the second step implies the third step. Now same way, suppose if I take x is more than 27, then x minus mu will definitely be greater than 27 minus mu. Then if I divide it by sigma, where sigma is the standard deviation which will definitely always be positive, so x minus mu by sigma will be definitely greater than 27 minus mu by sigma. Yeah. Now this x minus mu by sigma is nothing but z. So z is equal to x minus mu by sigma. So to find the standard deviation, you need to use this property. That means p of x more than 27 is 0.2, isn't it? That means p of x minus mu by sigma greater than 27 minus mu by sigma equal to 0.2. How? As I mentioned, x greater than 27 implies this. Yeah, this implies this and this implies this. So basically what it means is I can write it as p of this, I can write it as z more than 27 minus mu. That means 27 minus 25 by sigma is 0.2. That means p of z more than 2 by sigma equal to 0.2. Now from this I will find the sigma. How do I do it? Now if I want to represent this in the diagram, so I'll draw y-axis, x-axis. So definitely, since the area is less than 0.5, so this is where 2 by sigma be here. Yeah, isn't it? Because more than 2 by sigma, so this area. So this area is 0.2. Now here tail is right. So you have the area, you need to find the value. So what you do is go to distribution, go to normal, go to inverse normal. The tail is right. The tail is right. The area is 0.2. Sigma is 3. I'm sorry, sigma is 25 here, isn't it? Sigma is, I'm sorry, z, right? I'm so sorry. Z is sigma is 1 and the mu is 0. Okay. So enter. You get 0.841. That means this value 2 by sigma is nothing but 0.8416 or 0.842. So sigma is nothing but 2 divided by 0.842. 2 divided by 0.852. You can use a calculator to find the answer, right? I know that this is the first time you are seeing this type of problem. There are more problems of this type in the worksheet. So when we start doing more, you will definitely understand this much better. Yeah, let us go to the next problem, students. Okay, so I'm going to skip the third problem now for certain reasons. I'm going to go to the fourth problem, then we'll come back to the third problem later, right? So fourth problem is a random variable x is distributed normally with the mean of 450. That means mu is 450 and standard deviation is 20. So sigma is 20. The first question is find p of x less than or equal to 475. So a simple problem. Go to distribution, go to normal, go to NCD. Now I want the probability of x taking values less than or equal to 475. That means the lower limit will be minus 10,000, upper limit will be 475, sigma will be 20 and mu will be 450. So enter, execute. You get the answer, area as 0.8943. So 0.894 is the answer. Now the second part is p of x more than a is 0.27. Find the value of a. Now you can draw the diagram and do the problem, or without drawing diagram also you can do the problem. Now x more than a. So imagine it is on the right hand side of a. That means the tail will be on the right hand side. So go to distribution normal, go to inverse normal. The tail is right, the area is 0.27, sigma is 20 and mu is 450. So the answer is A equal to 462.25. So approximately 462 is the answer. Sorry, 462 cents. So in case if you have to represent this in the diagram, this is how it look like. This is the x-axis, this is the mean, that's 450, and this is the curve. So definitely it will be here. A will be here, right? This area is 0.27. Quite simple problem. Now let us look at problem number 5. It's a quite lengthy problem. A van can take either route A or route B for a particular journey. If route A is taken, the journey time may be assumed to be normally distributed with mean 46 minutes and a standard deviation of 10 minutes. So I have route A, mu is mean is 46 and standard deviation is 10. And for route B, the mean is not given, question mark, and the standard deviation is given as 12 minutes. Okay, now the first subdivision, first question is, for route A, find the probability that the journey takes more than 60 minutes. That means I want to find P of x more than 60 for route A. So more than 60 means 60 and above. So you need to go to distribution, go to normal, go to NCD. You need to find the area now, isn't it? The probability. So go to NCD. Now I want 60 and above. So the minimum value is 60. So the lower limit is 60. The upper limit is 10,000. And sigma is 10 because I am trying to find for route A. And the mu is 46. Okay. Now please be very careful with mu and sigma. Students sometimes in a hurry, what the students normally do is they enter sigma as 46 and mu as 10. So please be very careful. So the answer is 0.0807. So 0.081 is the answer. Yeah. So question A, subdivision A is a very simple problem. Now B, for route B, the probability that the journey takes less than 60 minutes is 0.85. That means P of x less than 60 minutes is 0.85. Find the value of mu. So you need to use this information to find the value of mu. So whenever you need to find, if they ask you to find mu or sigma, definitely you should convert the x into z, a normal variable into a standard normal variable. So x is a normal variable. When you say, if I use z, it is a standard normal variable. The difference is, for z, for a standard normal variable, the standard deviation will always be 1 and the mean will always be 0. For a random variable, a normal variable, the mu and sigma need not be 1 and 0. It can be any other value, any other positive quantity, right? Now, how do you find it? So, as I mentioned, convert this x into z. How? I can write this as P of x minus mu by sigma less than 60 minus mu by sigma equal to 0.85, which means P of this is nothing but z. P of z less than, now what is mu? We know that mu is 46. So 60 minus 4, I'm sorry. I made a mistake here. Mu, we don't know mu, right? I'm talking about route B. I was looking at route A. So 60 minus mu by, now the sigma is 12, isn't it, for route B, equal to 0.85. Okay. Now what I'll do is I'll take this as, let us say, some small a. So P of z less than a is 0.85. Okay. Now I need not represent this diagram, this information in the diagram. I can go to inverse normal, go to distribution, go to normal, go to inverse normal. Can you identify where is the tail, student? Is it on the left or is it on the right? It's on the left, isn't it? So less than a means a and below, so tail is left and the area is 0.85 and sigma is 1 for z and mu is 0. So the answer is 1.036. So A is 1.04. 1.036 or 1.04. So which means, let me erase this, which basically means this 60 minus mu by 12 is 1.04, which means 60 minus mu is 12 into 1.04. That means mu is 60 minus 12.48, which is nothing but 47.52. So the mean of root B is 47.52 minutes, right? Okay, let us look at the next subdivision. Okay, so this answer is 47.52, so 47.5, and sigma is 12. Okay, now the next one is the van sets out at 6 o'clock in the morning and needs to arrive before 7 o'clock. That means it needs to reach its destination within 60 minutes, right? Now the first question is, which route should it take? And the second subdivision is, justify your answer. Now if you recall, students, we found out that in route A, P of x more than 60 is 0.081. That means the probability of the van taking more than 60 minutes if it takes route A is 0.081. That means P of x less than 60 is 1 minus 0.081, isn't it? That means 0.919. This is for route A. Now for route B, it is given in the problem that P of x less than 60 is 0.85. Right? Now if you look at it, the probability of this is more. That means the probability of reaching the destination before 60 minutes is more if we take route A than route B. So the answer is, we should definitely take route A, and the justification is because the probability is more. Okay, so it's quite logical. Let's go to the next subdivision. Okay, on 5 consecutive days, the van sets out at 6 o'clock in the morning and takes route B. Find the probability that it arrives before 7 on all 5 days. So D is, it starts at 6 o'clock and it takes route B. Find the probability that it arrives before 7 o'clock. So this is subdivision 1. It arrives before 7 o'clock on all 5 days. That means the first day it arrives at 7 o'clock, before 7 o'clock, that means 0.85, and second day before 7 o'clock, and third day before 7 o'clock, and fourth day before 7 o'clock, and fifth day before 7 o'clock. So the answer is 0.85 power 5. Okay, 0.85 power 5. I'm sorry, this is not very clear. So 0.85 power raised to 5. So this is the answer. Now, what is the probability that it arrives before 7 on at least 3 days? Yeah. Now, this is slightly complicated, students. So what is the probability on 5 consecutive days the van sets out at 6 o'clock and takes route B? Find the probability that it arrives, the second subdivision is find the probability that it arrives before 7 on at least 3 days. So here I can actually use binomial distribution, okay, as part of the normal distribution. How is it? For me, the number of trials is 5 days. Okay, now I'll take success as getting on time. That means so in that case P will be 0.85, arriving at the destination before 60 minutes. Okay, now I need to find at least 3 days. So P of x greater than or equal to 3. Now you may want to verify whether it is actually this particular part of the question is actually, can it be considered as a binomial distribution? Definitely. Let us look at all the four the conditions, properties. The first one is the number of trials should be finite. Here 5 days, so 5 trials, so it is finite. Second one is there are only two outcomes. Either either the van will reach before 7 o'clock or it will reach after 7 o'clock. I mean, or exactly 7 or after 7. Third one is each trial is independent and identical, right? So whether the van reaches the destination on time or before time or whatever it is not going to affect the next day's occurrence, the event, whatever is going to happen. So the trial is identical and independent. And the fourth one is the probability of success remains the same. So the probability of the van reaching the destination, if it takes route B before 60 minutes, is always 0.85. So definitely it is a binomial distribution. So I can P of x at least 3 days means x greater than or equal to 3. So 1 minus P of x less than or equal to 2. So what I'll do is I'll take the calculator, I'll go to distribution, and now I'll go to binomial. I'll go to BCD, data is variable, x is 2 and number of trials is 5 and the probability of success is 0.85. So the answer is 0.027, 0.0266, so 0.027. The answer is 0.973. Yeah. So thanks for watching this video, students. So what we'll do is we'll solve the it's already 42 minutes, so we'll solve the rest of the problems in the second video, right? Thank you.